Hey YouTube, it's JP Dillon. Welcome to part 3 of the 1972 Pioneer sx-828. In the previous videos, we did an assessment, found that our volume control was defective, as was our high filter switch and loudness switch. We harvested those from various donor machines and was able to get that part of the machine working correctly again. So now we're going to work on some preemptive stuff. And the next thing we're looking at is the regulated power supply board, which is that guy right there. Now, commonly when you see this board, if they haven't fallen off already, these heat sinks will fall off because the screws that hold them together are plastic, and they did that for an insulative purpose. But really, those heat sinks don't come into contact with anything, so it's not really necessary. If you want to, you can use a mica insulator to insulate the transistor from the heatsink body, but really, for better thermal conductivity, I just remove the plastic screws or what's left of them, drill them out, replace them with hard metal, which has already happened here, and just use some heat transfer compound to the back of the transistor right to the heatsink. But more importantly, I want to talk about replacing the capacitors on this board, because they will cause all sorts of ailments. These ones here, I believe, are for a negative supply voltage that feeds the amplifier, which if goes dirty or less, will cause clipping, premature clipping. And that has to do with the muting circuit, I believe. And then we have our 30-volt supply for our preamp and our 12-volt supply for the tuner. So all these caps should really get changed out for reliability reasons. And if we have time, we'll also change the disgusting Chemicon caps on the protector board, which commonly leak. And then, yeah, we'll fire it up and see what else needs to be done to it still. I suspect that there's going to be some problems on the amplifier board, because that's just what happens, and we'll go over that too. But for now, let's focus on the power supply board. So let me get the camera mounted and we'll get this out. So one thing that you also have to be careful about is these plastic tabs that hold the board in, because they have become fragile with age, and you want to apply as little pressure possible to get them out. So I'll just take a hemostat here and I'll give it a little squeeze as I pull up from behind, just enough to get it loose. I won't squeeze very tightly. Again, it's just to get it loose. While I pull from behind, light squeeze until it comes out. Do the two at the bottom here. You may also want to remove wiring from these cable management clips. Yeah, the word for them escapes me right now, but that will give you a little more freedom. You gotta get these loose. And you can make a diagram, and you can unsolder and unwire wrap every one of these. But that's up to you if you want to spend the additional time. And then we have our board out in our service position, and we can fold it, one way or another to get to the solder side. Speaking of the solder side, so what you notice right away is that this area of the board here is much darker. Let's see if we can get some light on that. So this resistor down here and this transistor run particularly warm. So this area usually needs to be resoldered, but we'll address that when we replace the capacitors for sure. Most of the capacitors here are all the same value, which we'll discuss in a moment. Not a whole lot goes wrong with these unless they're high hour sets, but we're replacing the caps because of, preemptive longevity measures. It's going to make the unit more reliable and last longer. So that's typically why I will do that. But this is a 10 volt 1000 microfarad cap. These are 100 microfarad at 50 volts. These are 100 microfarad at 50 volts. And I believe that these are also similar. Actually, this is a 220 at 35. This is a 470 at 35. And then this is a 220 at 16, and I'll just replace that with another 220 at 35. So regulators, this is typically a 2SD313, sometimes it's a 2SD234, both of which are subject to opening base emitter. Don't see it very often on these, but where these transistors are used in higher voltages, like 70, 80 volts, they do fail. If you want to, change them out. You can use a TIP41C. That's a very good substitute. Very available. It's very rare that I see these die. I don't think I'm going to change them. Looks like this one's been changed already. It's got a fresh looking 2SD234 in there. They don't really run these at high enough voltages where they're going to fail. If we were looking like a Marantz 2325 where they're used also, they do fail. So I would change them in that machine, but probably not this one. But we are going to change all the capacitors here just because that's a must. So let's go ahead and get started with that. And let's just get our trusty wick. Really, the best way to approach this is to get something to prop this out. You don't want to bend and flex those wires too many times because of fatigue, which is why oftentimes people will simply unwire the board once and remove it, although I would argue that an equal amount of stress is placed on the wires trying to unwrap them and unsolder them from this. Right now I'm just desoldering all these capacitors. And although you can argue that, hey, it's still working perfectly fine, why not just leave it be? These components are 50 years old. And the big power supply electrolytics, which I test off camera, are still okay. They're still within about 10% or less of their rated value. And they're not leaky at rated voltage. So I'm just going to leave them be. I'll leave it up to the next person if they want to do that or not. But really, I'm just trying to focus on the aspects of the machine that are prone to failure, that would make it unreliable. And these gray Elna caps are prone to short or become leaky. They do open up too, in which case you'll get a nasty hum, which we weren't getting on this machine. But again, the regulator takes more stress than the main power supply caps do, because it's very unlikely that the person's going to be playing it at a loud enough volume that those big capacitors are going to be constantly charging and discharging, putting wear on them. But the regulator has to work pretty hard. So that's commonly why I will rework the regulators more so than just replacing the giant capacitors and nothing more. Which there are some shops that just do that. They'll just say, well, I put new power supply caps in and I'm sure everything else is cool. There was a place here in San Diego for a while, which will go unnamed, down by the coast, which used to just do basically cosmetic work. And they'd make the set look really pretty, but you'd get it back and there would be something dysfunctional about it, or the workmanship which would have been done on it was kind of poor. But I'm pretty sure he doesn't have a storefront anymore, so there's that. Just about have them all desoldered here. I like to do everything in groups, yank them in a group, and then install them in a group. That's just me. Let's see, this one here is a little bit, still got some solder underneath it. Okay, so those are all desoldered, and in theory, I should be able to just yank these. They come right out. They're dry. Well, that one's got a little bit of fuzzy stuff coming out of this side, so it was starting to fail. Oh, that one the lead came loose on. So I'm betting that one was gonna fail. Yeah, that's the other thing, is the leads will detach from the inside of these elements. That one's got fuzzy stuff at the base of the cap where the leads are starting to come out, so it was starting to leak. So yeah, they do die. And I just want to make sure that it's not going to be an issue. Let's see what the 1000 looked like. Oh yeah, that was definitely peeing. I think this is the one involved in making the negative voltage, because it's right at the anode of that single phase diode there. So that's our, this probably would have had the clipping error if we had cranked it all the way up. Let's see what this little guy here. Yep, he was leaking for sure. That little 220. And then there's the bigger 220. That one was starting to leak. And the 470, that's pretty dry still. All right, let's get our new caps and pop them in here. All right. We'll start with our 470. Bend the leads over the back. We got our 1000 up here. And we have our 220s down here. And we'll stick all of our 100s in here. And I use 105 degree minimum 5,000 hour caps. I tend to stick towards 8 to 10,000 hour caps. So I have a mixture of Kemet and Nichicon and Rubicon in here. Okay, so that's all our caps in there. Pretty simple. Not a whole lot to this one. And so we'll just come back over here and resolder all these guys. Clip off the leads, reinstall the board, power up, and see if the behavior of the machine has changed any. What I'm hoping for is the poor regulation bobble that we were getting at the preamp output that was making the audio bounce up and down at idle will kind of go away. We definitely have some better regulation with more smoothing of the DC, because these are very primitive regulators. They basically have a series of voltage dividers to get the voltage close to what they want, and caps to smooth it and filter it, and then they'll usually go through a Zener diode and a driver transistor that feeds a series pass regulator transistor to achieve a stable voltage, versus what they have now, which is typically like a monolithic 7815 or 7824 or whatever the voltage they're trying to achieve is. And it's good for about an amp on a single TO220 package. And those fail too, but it just means lesser components, less stuff. Not really happy with that solder there. Yeah, it's a little better. That 470 just has shorter leads. I ordered those by mistake, but they work in this application. Okay. These are all soldered in. Now we can just bring out the flush cutters and trim them all out. yes, I'm sure you noticed the brown wire floating. That's the 30-volt lead to the preamp, which we'll reattach. And that typically comes loose when you're servicing the preamp board, just because there's a lot of room for flex, and it does flex a lot. And then we'll touch up the area of the board that gets hot. So right here, all this gets fresh solder. That way there's a lesser chance that we're going to have a dry or failed connection in the area where there's a lot of heat. This one down here too. Okay. So that's pretty golden. We're going to very carefully set this board back down on its mounts. And if you want to apply the most even amount of pressure without risk of hurting the little plastic mounts or the board, because the board's brittle too, remember it is 50 years old, the trick that I use is a nut driver. And 1/4-inch nut driver should work perfectly fine. And you just place it over the peg here and just push very lightly, and it goes on. And it's less stress on you, the board, and the mounts. It applies an equal amount of pressure around the edge. What oftentimes you find is if you just press here with a screwdriver or some blunt object, this concentrated point of pressure will cause the board to crack there, wherever you press. So then you're just creating another headache for yourself. So let's clip this wire back. That's the one that reattaches to the B+ spot here on the board. And I'm just going to take some pliers and twist counterclockwise to remove the wire wrap. I don't like wire wraps. I'd rather just hook it and solder it. So we'll take our wire strippers, and then we'll get our needle nose and make a little eyelet, like so. And we'll slip that over the connection here and solder it in place. And just for kicks, we'll solder the post onto the board here because that solder looks a little bit dry. And then we'll solder the wire onto the post. And that will lessen the probability an oxidized or failed joint will cause a loss of voltage to the preamp. So there we go. So the regulator board's done. While we're at it, we should attend to these caps on the protection board up here, which this one's your timer cap, fast turn off, and then these are your allow low frequency to pass through. I think are 330. When you're in a tighter spot like this and you can't get your finger behind it, a dental tool is a good way to pull up and get force behind it so you can get the board up here. And again, just enough that we can get the board up. Want to be as gentle as possible. The preamp board's a little bit in the way on this one, but it's not going to stop us. And this is just an area that I can't really get my hands into, so that's why we have tools. Give this one a pinch, and a little bit of a tug here. And then finally, the one up here as well. And there's our protection board. And this is really easy to get to. It just folds down We have our solder side right here. So these are little 330s at like 16 volts, 6.3 volts. It's really tiny. 100 at 16, and then this is like a 4.7 or a 10, I think. We're just going to change them all out. It's a good idea. If these guys fail, like they get leaky, they will cause false triggering. If the timer guy fails, if it opens, you'll have immediate protection circuit closure. So you'll turn it on, the relay will immediately come on. And you can raise this from 100 to a 220 to change the time interval. So more capacitance equals more time. And then this is your fast shutoff, I believe. So there's a single rectified, half-wave rectified voltage that goes into here that barely keeps this circuit on, which keeps the relay closed, so that as soon as you remove power, this discharges quickly, which causes one of these transistors to go low. It's like a PNP with a positive voltage on it that goes away, which then turns on the NPN, which then clamps the final transistor down here that fires the relay, or some such thing like that. I forget how the circuit works exactly, but it's pretty close. Also, noisy transistors in that area will cause intermittent triggering of the protection circuit. You don't see that too often on these ones. The later ones that use like 2SC 945s or 2SA 726s, stuff like that, they tend to fail more often than these older ones do. And I'm just going to suck the solder off these, or wick it off rather. Pull these guys out just like the power supply. Replace them. And then we'll turn it on and see what it's doing. And if everything's working cool, then we can move on to the next thing, which I think is going to be the phono stage. And then maybe we'll work on the power amp too if there's time after the phono stage. There probably will be. But it's just all a matter of available space on the camera. I really only have about 45 minutes worth of recording time on this one, which is fine because I don't want to spend my whole morning on this thing. Plenty of other stuff to do. And then when I'm done with this and with the Emerson, then we get to face the joy of the famous Sony dual cassette, the TCWR820, that has come back. Actually, this is a 4.7. I thought it was 4.7 or 10, one of the two. It's back for a mechanical failure, which is going to require that we have another transport, which I do have to swap, because aging plastic parts. That one kind of splooged everywhere. And let's see here. There's these ones up top. These 330s, which I believe are partially glued to the board. Yeah, these ones are glued. Come on out. Yeah, the bottom of that's wet. All these, whenever you see this logo, this United Chemicon or whatever it is, and they're black and they're 70s vintage, replace them. They're all bad. Every single one that we pulled out of this machine thus far has been leaky. And that seems to be true of other ones that I've worked on as well. That one got pretty wet too. So they're all just failing. Kind of like the purple Panasonic capacitors that pee everywhere, but it's the same thing. They're all failing. Let's get the new caps. All right. So first we have our 4.7. Then we have our 100. have our two 330s. I use 16-volt devices because that's the lowest voltage I have. That ain't going to hurt anything. The original ones were 6.3, so that should be okay. So a little bit of glue here at this opening I want to remove. Man, he just don't want to come off, does he? There we go. The glue was covering the hole, and so there would be a chance for the glue to become corrosive and eat that lead, which I don't want. Alright, so now that those are in, let's go ahead and solder them up. And unfortunately, some stuff's going to get in the way here while I do this. There's the 330s. There's the 100, and here comes the 4.7. Alright, so those are all soldered in. Nice clean look there. And so we'll trim the leads off. And we'll stick the board back in. You're going to have to fight the tight quarters here a little bit, but it's not impossible. And we'll get our nut driver again and give this a little push. All right, everything's in. So let's hook it up and let's see where we're at as far as performance. Okay, so we're going to turn this thing on now. We're keeping an eye on our scope. Let's see, why do I only have one channel here? That's weird. Did the volume control I just installed go bad? What happened here? That's bizarre. We still have a little bit of bobble, but I'm pretty sure that's from the 5G noise. Interesting. Let's pull that board out again real quick. Okay, so here's the weird thing. If I operate this thing outside, I mean, short of the fact that this is not grounded, we're picking up noise. In fact, if I just clip to ground here, get rid of some of that noise. The volume control works cool. Nice and linear and smooth and whatever. But when I reinstall it, it ain't happy. Something's shorting out. Not sure what. I think it might be one of these loudness taps up here that's touching up against something. Because it was totally shorting out the output. Don't mind me here. I'm just going to get aggressive with moving wires around. I'm sure I'll break something. Let's see if I can replace these. Move these to a different position. That little noise there at the bottom, that's relay funk. If I tap near the relay, it goes away. But yeah, volume control works perfect outside the unit. Let's reinstall it back in the unit. All right, so we're loosely back in the unit now. we're good there. Might have just been that part of the loudness control was touching something it shouldn't oughta. So now we're going to start putting screws back in and washers back on until we see a failure. And if so, then we know that something that shouldn't be touching ground is touching ground. But first of all, let's just start reattaching things. And yeah, the bobble is in fact the 5G noise I'm getting from the tower. Cell noise, whatever you want to call it. It only started happening when they put the 5G up. That's why I assume it's 5G. Everyone tends to tell me, oh no, that can't be it. That can't possibly be it. It's not doing that. Yet the FAA is all over the FCC because of interference with flight control stuff. And you can see there, it's really getting into the receiver. So far, so good. Let's put our balance control back on. Sometimes you run into these things. Oh, that's because I moved it. Silly me. Tighten that down. Yep, still good. Put the volume control back down here. See if I can move this over a little bit so my hand's out of the way, at least a little. Nope, still doesn't work. All right. Let's tighten this down. The tightness of that nut really determines the smoothness of the control. So I'm thinking there was maybe a slight misfitment there, so I'm not going to tighten it all the way down. I will put some Loctite on here though, or some scary green stuff. But the channel out problem has seemed to have gone away. So let me go get the drape, and we'll put the drape over this, and I'm pretty sure all that bobble is going to go away. And so if I hang my little RF drape over it here. Forgot this has metal interwoven with it. But yeah, that definitely makes the bobble go away. I've created a new problem because I let it breeze in here. I probably touched one of these spots here. Yeah, so we heard a driver transistor. But that's okay because that board's coming up next. And if yeah, it's definitely left channel only. So somewhere in here, I probably hurt one of these pre-driver transistors. Not a big deal. But you can just see the noise riding there. Just awful. So that's the problem with having to... And it's load dependent, so it's definitely a driver issue. Well, anyways. In fact, if I want to prove it all the more, we can rest the bottom cover there like we should have done in the first place. And then rest the RF drape over it. And now we see it's totally still. So take that away, and we have a little bit of bobble. Remove the bottom cover, and we have lots. So it's definitely tower interference. So in the next episode, we'll fix my botched amplifier that I just messed up here, carelessly putting the drape in the way. And then we'll work on the phono preamp as well. And we should get this machine working very nicely then. and then we can do some tweaks on the tuner and stuff. But for now, our power supply is good. Our protection circuit works. I got to take up the amp now because, well, capacitors and because I made a mistake. But anyways, hope you guys enjoyed this segment. Stay tuned for part 4. We'll tackle the amp and we'll tackle the phono stage, and then we can get to really enjoying this machine. Until then, thanks for watching. More stuff to come.